So I've just finished the wiring of my first home-built kind of custom design with existing parts or whatever 3-axis CNC controller. Now this unit is 3-axis, but it's going to be used on an engraver, which is 2-axis with a pin up and pin down. So the Z-axis is that pin up and pin down, but this could be easily used for any other small CNC, 3D printer, or anything like that. The board and everything that's in there actually can do 4 axes itself, and I'm going to kind of go over the components here and everything and how it's laid out for when I do my tutorial. So if we look at the front here, we've got your basic run, pause, and stop for your programs. Currently the way that this is set up is it has a USB connection on it. You connect a PC to it and use that to actually push the program and everything and run it on here. You can add like a adapter for an SD card and run it that way, and then use the run, pause, stop to basically just automatically run whatever's on an SD card that way. I have an emergency stop button here on the front. This should make it easy because this will be sitting right next to the engraver that it'll be running. And this is a software emergency stop though, so it doesn't cut the power or anything like that, but it does lock the stepper motors and should shut off the spindle as well, or the PWM output should go to 0, or basically turn that off when you hit that. Run obviously starts the program. Pause. These are both momentaries. This is a latching switch. So here when you push this in, it will just pause the program, whatever line it's at. It'll just pause it right there, and you can resume it just by undoing that. So you could use it for tool changes, stuff like that, but you probably just want to actually have that in the G code or the program that you're running. And then stop just stops the program. It doesn't do an emergency stop. It'll just stop it and then re-zero out the system and everything. If you look here on the side, you can see the largest and heaviest components of this. We've got 2 power supplies. The top one is a 24-volt power supply. The bottom is a 48-volt power supply. I don't remember the exact wattages, but I think this one must be a 240 watt. I think this one down here is like a 400 watt 48-volt power supply. The 24-volt power supply powers the stepper controllers over there directly, powers the controller board itself directly, and powers this DC 24 to 12 volt converter here to run 12 volt items in. Basically the fan is the only thing connected to it right now. But eventually, if you were to do a different variation of this or something, you could have a display on the front. You could use 12 volt to power that and stuff, or even bring that down to 5 volts if you needed to. And we can kind of see here the wiring in the back here. So everything is crimp terminal connector. It's connected back here and there, and on the outlet inputs back here for the power, to make it so that you could pull the panel off relatively easily and undo that. But they're secure. So here we have the 2 separate power inputs. I decided to separate this because sometimes if you're going to do a diamond drag or you're going to do a plot or something like that, you don't want a spindle to be running. So this will let you control that separately from the 24-volt power. These are separately fused and everything as well. I'm also separating this, and this varies. The previous system that this is to replace, the spindle motor was just 120 volt, was not variable spindle speed or anything like that. So this whole system is different from what was there previously, as in it's 48 volt power supply from 120 here to DC, going through the motor controller right here. So this is a variable spindle controller, variable speed spindle controller. You can see that there's a power input, the output, and here we have the PWM connection to the controller. There's also a connection there for a pot that'll let you change, basically analog, change the spindle speed. So hopefully this will give a little bit more use options for the engraver and everything, but be able to have that adjustability. There's the stepper output. This is from the existing table, the machine table and everything. This is what was used to connect the original stepper motors and all that. So I've am reusing this because I really like this type of connector. It's the 14 pin, and I can't remember the exact name of the connector, but there's a cable that goes from here to the table and everything, and that'll be wired up. You can see the USB I/O there for actually controlling it. And then over here we have the spindle, e-stop, and limit switch, or the limit switch inputs there. So these all just have the blanks on them right now. There's a 4-pin there. This is eventually if I want to have a speed sensor maybe with a spindle. The one that I have is just a 300 watt 48 volt spindle. It doesn't have a speed sensor or anything in it. But right now it's just connected negative and positive on the diagonal. And I could add a speed sensor or something into this whole system later. The e-stop is a simple 2-pin. And those will be normally, let's see here, normally closed switches. Or actually, sorry, normally open switches. So if you hit any one of the two, the external one, which I have wired up to a little external e-stop switch, and the one in front, if either of them, when the connection closes, it'll stop the unit. It's kind of the opposite of how it would be done, I think, on some of the bigger systems, because you want it to always have a signal going through, and if it breaks, if somebody disconnects or something like that, then it stops the system. They could be wired either way, honestly. This just makes it easier so that you don't have to have a jumper here in case you don't want this. You just don't have to have it connected if you don't want it. And then the limit switches, because the board had a setup for 4 limit switches, and then there's a ground pin on there as well. We won't be using that many. We'll probably be using 2 limit switches, maybe 3 on the pin up, pin down axis. But that's just in case this ever wants to be expanded or reused in the future for anything else. So if we go around to this side here, we can see I've got the X, Y, and Z stepper motor stack here. These are the controllers. They're set for 1.5 amps, and I think it's set for 1/4 step per step, or whatever the resolution of the motor is that way. That'll all be adjusted and everything. The amperage will be the same, but the actual resolution of the motor will be adjusted once we dial in the table and everything, which I obviously don't have here. And then, like I showed you earlier, there is the speed controller. It's got a pretty big heat sink on it that's mounted directly down here. And I've got a fan here at the front that'll hopefully create enough airflow through here to help mitigate any heat issues or anything like that. I also stack these so that the X and Y are on top of the Z, because the Z is basically hardly ever used, so it shouldn't get that hot or anything. The hotter ones are at the top to kind of keep the heat away from there. And then we have the ribbon cables that connect these to the main controller board. Now this is a CNC-USB board. This is a company out of the UK, I think. I found this and everything, had my dad order it and all that. It was not that bad. I think the price for this board was about $110. Plus there is a software license of like $70 for the CAM software for this. So whatever. It's overall the systems to build this out by hand has taken probably most of the actual effort in this has been about the last 2 months, but the research and getting all the components together, everything like that, has probably been about a year of just spare time kind of thing. You can see here we've got the e-stop inputs there, the regular inputs, and that's for the front panel buttons over here. The limit switch inputs, and then the output, and there's a ground there, and that is for the pulse width modulation out to go to the speed controller. Lastly here we have the power input and the USB connection. And that's really it. I mean, it's pretty simple. Everything's kind of plug and play. It's just actually getting the case designed and everything like that and putting it in a nice box basically. Otherwise, there's really not much to this. You can connect a jog wheel controller here, so this can do, you can connect to like a front panel if you want to have a display up here maybe to show the current G-code like position and stuff like that. And then have some buttons near it where you can jog, you know, X, Y, Z, plus, minus and all that. You could do that with this. There's also a kind of a pendant controller you can plug into this unit here, which is like a 25 pin output. And if I wanted to, I could build that into the back here, have a parallel output. You could have an external handheld display slash, actually I don't think this does a display with that, but it'll do like the jog wheel and everything, and have an e-stop and all that stuff on a pendant. But for this, it's all going to be computer controlled just off of a laptop for now. Yeah, and then otherwise, just a 12 volt 80 millimeter fan there, and I think that's it. So hopefully I'll have another video coming up of getting this system plugged in with the table and the new steppers and everything that were added there, and getting it up and running.